433 is an interesting question. We're presented with a number of cash flows, and we have to figure out how to match these cash flows. The question overall states that your father is 50 years old and he's planning to retire in 10 years, and he's going to expect to live for 25 years in his retirement. And suddenly at age 85, who knows what happens, but that's the end of the plan. He wants his first retirement payment to have purchasing power of $40,000 today. And what this is saying is, in 10 years when he retires, he wants that money that's drawn out in 10 years to be equivalent in purchasing power today. But after that first payment is taken, there will be no further adjustments for inflation. So there is a recognition that the purchasing power of the payment will decline over time in retirement. He'll begin drawing a retirement income 10 years from today, and he will receive 24 additional payments for a total of 25 payments. Inflation is expected to be at 5% per year. So that is, the purchasing power will decline by 5% per year. He currently has saved $100,000 and expects to earn 8% per year. To the nearest dollar, how much must he save each year for the next 10 years in order to meet his retirement goal? So the way that the spreadsheet's set up is, I want to point out really clear, we're recognizing their savings of $100,000. When he retires, he wants to have an amount equal to $40,000 today, so we'll have to calculate that amount. Inflation's 5%, savings will grow at 8%. Things we need to identify are as follows. Well, we know that we're presented with cash flows in this problem. There's a lump sum of savings, which is the $100,000, an annuity stream that builds the retirement wealth. So for the first 10 years, there's going to be an amount that we're going to save, an equal amount that'll allow us to offset the drawdown. There's a future value to be drawn in retirement, and that's that $40,000. So we have to figure out, in 10 years from now, accounting for 5% inflation, what's going to be that future value to be drawn in retirement. And lastly, that future amount drawn in retirement is going to be an annuity stream, because we're going to withdraw that amount for 25 years, and so that's going to be an annuity cash flow. However, note that the retirement income will be drawn the first day of retirement. So what that tells us is that the annuity is going to be an annuity due, since it's received at the beginning rather than the end of the term. So there are a number of different types of cash flows we're dealing with here. We have a lump sum, we have a present value of an annuity, or rather a future value of an annuity, a present value of an annuity due. And so let's get started. So the way that I've also set up the chart here, so for some of you that are visual about this question, or the visual aspect will help you. Note that we have the age here at 50, and the father is expected to live till age 85. So what we can do in reverse is identify the 25 years of cash flows. And so we can see from 61 through 85, these are the cash flows that will be drawing down the retirement savings. We can then, in reverse, identify the years, that is the countdown to retirement. So you'll see that the countdown to retirement is in black, and in the retirement, drawing down the savings is in red. What the cash flow looks like today is there's $100,000, then there's going to be a series of equal payments that will be used to build the retirement, and then at the first day of 61, drawing down the retirement. So first we need to calculate how much will be drawn per year in retirement. So we need to calculate the future value equivalent to the present value. So our formula is going to be equal sign the present value of 40,000 times 1 plus the inflation rate to the power of 10. So that's going to give us the adjustment for the 40,000, but in value 10 years from now. We see that that amount is $65,155 and change. So that you understand the cash flow process here, we can go to year 61 and say equal sign is equal to the amount that's going to be withdrawn in retirement. We'll hit F4, and then we'll simply fill this value in all the way down. So we can see then for the next 25 years, we're going to draw out $65,155.79 per year. So then we need to figure out how much do we need to save in this period in addition to the $100,000 in order to the equivalent to that amount. So you can see that the point in time that's referencing is right here between ages 60 and 61. This is actually going to be the present value. So everything in here, these 65,000s that are retirement, these are future values. And this is an annuity because it begins and ends. It's an equal amount. So what we're saying is right here we're going to find the present value of an annuity due. And at this point also we're going to find the future value of an annuity plus a lump sum, that being the 100,000 in savings. So first, let's find out what is the present value of that annuity due. Rather than use the long formula shown over here, I'm circling with the mouse right now, that is the present value of an annuity due, we can just go in Excel and say equal sign PV. We'll identify the savings rate, and then we know the number of periods is 25 for our annuity due. That is, we're going to have 25 payments at $65,155.79. The payment is the $65,155.79. The future value is going to be 0, and to tell Excel that we want this to be an annuity due versus an ordinary annuity, we hit 1 for type. If you're not familiar with this setup, when you start this function, you'll notice that Excel provides you this little guy below, and you just click on PV, and up will pop a help box, and there will be descriptors of each component within the function. So what we're finding here is there's a present value right here at retirement of this annuity, and it has a present value 10 years from now of $751,165.30. We then need to figure out how much do we need to contribute in this period in order to fund the retirement. So we're going to just say equals future value, our rate, number of payments is 10. Sorry, we're not using future value. We want to figure out how much we're going to pay. So we'll do payment, our rate, number of periods is 10. We have a present value, and we'll put a negative sign in front of this. Let's leave it positive, of 100,000. Our future value is going to be the retirement need, and it's at the end of the period, so we can just leave it blank. So what this is telling us is that we're going to need approximately $36,000, almost $37,000 per year in savings, or your father is rather going to need almost $37,000 a year to fund the retirement goal. That will produce a future value at this point in time of $751,165. Now I know this may seem a little strange, and you're going to want to double check the math. So how would we go about that? So again, notice here our functions within the payment. We have our rate, 10 years of growth. We have a present value of the 100,000 and the future amount of $751,165. So we should try to get to that amount. What this looks like is we're going to have cash outflows. That is funds going into retirement of that amount. And also today, what do we have? Another amount of 100,000, right? That's already saved. So we want to double check this just to make sure. So the way that we can do this is equal to a future value, 0.08, number of periods, 10. We'll leave our payment as the contribution. We can also put in our present value of 100,000. and it's at the end. And so what we can see here is these values do actually match. So hopefully that helps clear everything up. And what's going on here is we're saving an amount, it's growing, and all these cash flows equal each other in the end. So the 25 years of drawdown have a value right here at the end of age 60 of this 751,165, and the 100,000 plus the additional 36,949 and change contributed each year for the next 10 years will be of an equivalent amount. That is, in total, they sum up and cancel each other out.